This lesson is let B be B1, B2, and C, C1, C2 be the basis of R2. Find the changes of coordinate matrix from B to C. This is the notations. This is how we write B to C. B to C. And C to B. This is the notations, how to write C to B. Okay? Here is our vector 1, vector 2 for B, vector 1, vector 2 for C. Now put this together as one matrix and be very careful when you put them together. C goes first and then B. The reason is we want B to C. One more time, the reason why C first and then B second is because we want B to C. Now we do row operations or row reducing, and we can get our final answer. So this is a 1, so we leave it alone. This 4 needs to be a 0, so opposite of 4 will be -4 right here, -4. So -4 times 1 will be -4 plus 4 gives me this 0. -4 times 1 will be -4 plus 1 gives me -3. -4 times 1, -1 will gives me +4. 4 plus 8 gives me this 12. -4 times 1 is -4 plus -5 gives me this -9. Next, I need this -3 to be a 1 over here. So the reciprocal of 3 is 1/3. Put another negative in because I have another negative here. So there's a negative and negative, so become positive. So -1/3 times -3, +1. -1/3 times 12 gives me -4. -1/3 times -9 gives me +3. Okay. Next, I need this right here to be a 0. So opposite of +1 will be -1. So -1 times row 2 plus row 1. So -1 times 1 will gives me -1. Subtract 1 gives me this 0. -1 times -4 gives me +4. +4 subtract 1 gives me +3. -1 times 3 gives me -3. Plus 1 gives me -2. So as you can see, I have 1, 0, 0, 1. We are completely done. This part right here is the answer we are looking for. So 3, -4, -2, +3 is our B to C. Okay, one more time. This right here is the answer for B to C. Now we are looking for C to B. Okay, so this is the answer for B to C. Now we are looking for C to B. So we will find the inverse of this. Then we need the determinant. So to find the inverse of this, we must find the determinant first. So A times D, which is here, minus B times C, which is here. Simplify, this gives me 9, this gives me +8, but I have another negative, so it becomes -8. 9 subtract 8 gives me this 1. Let me move this up a little bit. Now again, this is the formula for 2 by 2 only. This does not work for 3 by 3 and so on, only 2 by 2. So 1 over the determinant, AD is being switched, AD is being switched. However, both of these numbers are 3, so you didn't really see that it got switched, but you have to switch, okay? B and C, put an extra negative in. So there's an extra negative, so negative and negative become this +2. Extra negative, so negative and negative gives me +4, okay? So 1 divided by 1 is just 1. 1 times the whole thing is back to itself. So this is the answer for C to B, which is also the inverse of B to C. One more time. This is the answer for B to C. This is the answer for C to B, which is also the same as the inverse of B to C. Okay, next I'm going to go down here. So this is another method to find the inverse for any matrix, n by n matrix. So 2 by 2, 3 by 3, 4 by 4, 5 by 5, and so on. On the left side is the matrix that I want to become inverse. The right side is the identity matrix. Our objective is to make this identity from right to left. That's what I have here. And move this matrix to the right, which I have here, and then it will become the inverse. Okay, so this 3 right here needs to be a 1, so I multiply the reciprocal. So 1/3 times 3 gives me this 1. 1/3 times -2 is -2/3. 1/3 times 1 is this 1/3, and then 1/3 times 0 is this 0. Next, I need this -4 to become a 0. So I'll multiply the opposite, which is +4. So 4 times row 1 plus row 2. So 4 times 1 is 4. Subtract 4 gives me this 0. 1/3 times 2/3. Okay, so 4 times, let me do it again. 4 times 1 will gives me 4. 4 subtract -4 will gives me this 0. 4 times -2/3, which is this one right here. So 4 times -2, which gives me -8 over 3, plus this 3, which is here. Since the denominator are not the same, cross multiply gives me -8, cross multiply gives me 9, under multiply gives me this 3. Now you add subtract the top, so 9 subtract 8 gives me 1/3. So this 1/3 is this 1/3. One more time, this 1/3 is this 1/3. Okay, next 4 times 1/3 is 4/3 plus 0 is this 4/3. 4 times 0 is 0. 0 plus 1 is this 1. Okay, next I need this 1/3 to be a 1, so multiply a 3. 3 times 1/3 gives me this 1. 3 times 4/3, the 3 go away, I have 4. And then 3 times 1 is this 3. Next, I need this right here to be a 0. So multiply the opposite of it, which is +2/3. So 2/3 times row 2 plus row 1. So 2/3 times 1 is 2/3. Subtract 2/3 gives me this 0. 2/3 times 4. So 2/3 right here. So 2/3 times 4, which is this 8/3. So 2 times 4 will be 8. Okay, and then don't forget the 3 plus 1/3, which is here. Since the denominator already the same, just add or subtract the top. So 8 plus 1 gives me 9. 9 divided by 3 gives me this 3. So this 3 is this 3 here. Okay, 2/3 times 3. The 3 disappeared. Cancel out. I just have left a 2. 2 plus 0 will gives me this 2. And as you can see, this is the same as up here, which is the inverse. Okay, so this is the same as up here. Now, what I did here is only 2 by 2. What I did here, you can do 2 by 2, 3 by 3, 4 by 4, 5 by 5. Okay, so one more time. We are looking for B to C, which is this answer. And we are also looking for C to B, which is this answer. However, this answer is also the inverse of B to C. And also, this formula is only 2 by 2. This method will do 2 by 2, 3 by 3, 4 by 4, 5 by 5, and so on.